Okay, just a very short video. We are going to discuss two questions on arc length and area of sector. Now, I want to inform you in your examination, okay, on the second page, you have this formula sheet, right? Okay, the formula sheet contains this compound interest formula. It contains your mensuration sort of formula, and very importantly, it contains, we just revised this yesterday, right? Arc length, the formula is r theta, okay, where theta is in radians, and also the area of the sector, half r square theta. Remember, we did this just yesterday, okay? So if you forget, in the examination, these two formulae, right, you can refer here. Also, you have sine rule and cosine rule. You can refer to these two here, okay? Now, we're going to go through just two questions for this video. Okay, I think it's from your homework. You check because somebody asked about these two questions. Now, this is the question 3 from 2016 class quiz. You go and check. It might be in your homework. But if it's not in your homework, then never mind, I just try it out, okay? So the question goes like this. You have O as the center of a circle. Okay, so this center is O here. And it has a radius of 5 cm. That means I told you already, from the center anywhere to the circumference, anywhere, right, is 5. Okay, so you just label 5 lah. And the reflex angle, right? Reflex is, okay, remember, a cube is a small cube angle, right? Then if I draw a straight line from here, this is called obtuse. Okay, so obtuse is greater than 90 but less than 180. Then if I have a cube here again, this very big angle here is called reflex. It's like want to rotate one whole big round, but not one whole big round. So we call it reflex angle. Right? You need to know all these names. So the question wants you to, the question tells you that the reflex angle, meaning this big one, okay, is 4.5. Okay, now you are supposed to find the area of the major sector. Remember, this, like a piece of cake cut out, is a sector, but this is a minor sector. The major sector is the big one that remains after you have eaten this small piece. So how do I find this area of sector? If you recall, okay, if you cannot recall, you refer to your formula sheet. There, half r square theta. Very simple. The theta must be in radians, right? So this question is very simple. Theta is this fella. Okay, r is 5, and then you can find the answer already. So that's all. Alright, then you write the answer in unit, cm square. Okay, very simple to remember. Is here half, and theta no unit one, right? Theta is in radians, but radians is just like a fraction, okay, a ratio. So no units one. So that's why you have to square the r here to get the cm square, because this is 5 cm. Okay, now let's go to the next one. They ask you to find the obtuse angle AOB. Wow, that's even easier. Obtuse is this one, correct? So how do I find this obtuse angle AOB? Obtuse angle AOB, you know the whole one round is 2 pi, right? So you just take 2 pi minus 4.5, finish already. Okay? Wait, let me see. Did they ask you to leave in pi? Okay, if they ask you to leave in terms of pi, you leave your answer like that. If they didn't, right, you just 3SF it. Okay? So that's all. Now, for radians, right, you can either write radians or write RAD as short form, or you can just leave it. If for angle, you don't write degree, right, it's understood to be radians already. Okay, so don't bother. That's all. First question. Oh, haven't done. Wait, there's part C. Find arc length for the minor sector. So you see, you must be very conscious whether they want minor or major. Minor is a small one, right? So how to find this? We already know this. Whatever is here is this thing, right? This triangle, the value, I'm just telling you, this triangle is this value. Okay, now to find the arc length is r theta, right? So it's just they want minor or major? I think they want major. Okay, so major minor, sorry, the one minor. Okay, minor sector, the minor sector is this one, right? This one, so you take 2 pi minus 4.5, okay? Then you go and find your answer in 3SF. Alright, that's all for this. Thank you. Okay, sorry, haven't finished yet. Got another question here. Another question is question 5. Alright. I think this is in your homework, I believe. Okay, the question goes like this. This one is slightly tougher. It's a question 5. Then the shaded part is actually here. Later then I shade, alright? Okay, you are given that the radius of the bigger circle is R. So there's one big and one small circle. This radius is R. If this is R, this must be R, right? Okay, then given that the radius of the bigger circle R is the diameter of the smaller circle. Okay, I don't know whether you understand this or not, but what it means is that this R is the radius of this big one, right? Okay, but R, this length is actually the diameter of the smaller circle. Diameter means the whole thing, right? From here to here. Okay, so this means that this radius of the small one must be half R or R over 2. Okay? Yeah. So, so simple, finish already. They ask you for the radius of the smaller circle in terms of R. Isn't that half R? Finish. That's all. Okay. The next one, given further that R is 4 cm. Okay, now we know that the radius is not only just known as R, it is actually 4 cm. Okay, so we can label here 4, 4, and then this one is 2 lah. Okay, so that's what I'm going to do. I label here 4, 4, and half R means 2, right? 2. 2, then this must be 2 lor. Okay, okay. They are going to find angle CYX. CXY, sorry, CXY here. How to find? Okay, so if you know this arc length, you can use arc length equals R times theta, that formula, then you can find the answer already, right? But we don't know this. So how? We don't know this, right? You think about it, okay. Assuming you thought about it already. So you see, we are smart human beings. So I draw a line that's parallel to this CF. Don't you agree that this will be 90? And don't you agree that this and this, they are vertical lines? So this is this CX must be parallel to this FY. Correct? So if they are parallel, if this is 4, this is 2, this must be 2, 2 lor. 2, then this must be 2. That means I can find this angle. If I call it theta, don't you agree that there's a right angle triangle here? And I know the adjacent. This is the adjacent. And I know the hypotenuse. This is the hypotenuse. 4, right? Okay. Then I can find my CYX. Okay. This one I use I use algebra to do it but actually you can do it this way. You can say that this is 2, this is 2, right? Okay, then this R, this half R, so this whole thing is 3 over 2R, and that will be 6. 3 over 2 of the R, that will be 6. Okay, this whole thing is 6. Yeah, then you have the adjacent, you have the hypotenuse, you can use cosine, and then you inverse cosine, you can find the answer. Okay, notice for this area of sector arc length, right, I always use radians, because when I want to apply arc length equal r theta, or area equals half r square theta, this theta must be in radians. I don't believe you go and see the formula sheet that I showed you just now. Okay, yeah, so done already. Now last part, find the area of the shaded region. Now where is the shaded region? The shaded region is here. and here. So don't you agree that using symmetry, okay, my diagram not drawn to scale, but can you see that if I were to draw here, okay, and here, this will be 90, this will be 90, right? So it's like a reflection. Can you see it's like a reflection? This trapezium and this trapezium is a reflection. So this area actually is the same as this area. Okay, and how do we find this area? Very simple. I tell you how we can do it. First of all, we find the whole idea is this. I want to take this whole trapezium, right, which is x, c, f, y. X, c, f, y. Don't you agree that's a trapezium? I take this trapezium minus off this big sector. Can I find this big sector? Definitely, because this is this theta I know, right? Just now they asked us to find already. Where? Here. Okay, cxy. See, cxy. So the theta I know already, right? Okay, so I can find using half r square, which is 4 square theta. I can find this white part, white sector. Then I can also find this angle. How? Don't you agree just now I said these two are parallel? So interior angles of parallel lines, they add up to 180. 180 in radians is 2 pi. So I just take 2 pi minus this angle. That will be this angle. Then I take half 2 square of this angle. I can find this white part. So I take trapezium minus this white part, I get the answer. Finish. Okay. Now, the only problem, you see, I know that this, area of trapezium is half sum of the two parallel sides, meaning A plus B. Then times the distance between them, right? We call H, right? Okay. I know this is 4, not a problem. 2, 2 ma. I know this is 2, so I know all this already. That means it's half 4 plus 2. But I don't know this. But can I find? Definitely. You see, if I want to find this, I draw a line parallel to it. Then isn't this line part of this triangle? Then I can use Tuakaso. Okay, this is opposite hypotenuse. I can find this side because I already know this angle. So that's the whole plan. Okay, that is what I've done here. So I know WY. I call this WY. Found already, right? Then I use Y2 because this and this the area are the same. So these two, you understand? What is this? Area of the trapezium. That's this whole thing. Okay? What is this? This is the half r square theta. That means the big white sector. Okay? Then minus of small white sector. Okay? And that's half r square, 2 square ma. So r square. Then this theta, right, I told you already is 180 minus this, but you cannot use 180 because these are all radians. So you take 2 pi, which is 180. Not 2 pi It's pi, not 2 pi Yeah, blur already. Haven't had dinner. Okay, so this is 1.23 something. Okay, you take pi. Sorry, just now I said 2 pi, right? It's pi. Pi is 180 degrees. Okay. Yeah, okay, don't be blur like me. Okay, so it's pi minus this. Pi is 180, but you don't write 180. Okay, then go and check answer. Any mistake, let me know. Okay, I continue after dinner. Thank you.